Okay, so that should be streaming now. I hope. Do you see it now?
With the same link?
Oh, I should give you a new link. Hey. So for that, let me see. Settings, stream. It's doing that. I think that then the settings are. It's not here because that's the old 9-minute one. But then if I'm here, there we go. We've got a live link to it. And let me see. I can update the QR code for it real quick if you need me to. Let me go to it. Where is my thing? Oh, wrong one. I'm gonna go to it. To one of these. This. There we go. That is the QR code for the current stream if you need it. And now that we've done troubleshooting, hopefully we're back on track.
Mm-hmm.
Here we go. Does that work for you? Sure thing. All right, I'm going to get back to it. All right, so this view here is the schematic editor. And the schematic is where it's kind of like drawing pen on paper, laying out where you want for all of the components to connect. This is totally separate. It's separate from the PCB view, which is where you're dealing with the physical components of it. But this side is electrically where you're going to specify how you want everything to connect together. And so to get started with making our circuit, we want to add some schematic symbols on there, which will represent the physical parts, which we will set up later. And so for this, we want to place some symbols on here. Within this view, this has all of the components that are set up within Kicad. It is an insane amount of stuff to scroll through, so it's very helpful to filter what it is that you're looking for. And there are a couple of just simple filters that you can use. We want to just set up a LED. We're not worried about telling it what kind of LED right now, so we can just choose the LED symbol for it. And then I hit R to rotate it. I'm just going to drop that into place. And so we still have, you can see on my cursor that it still has the same symbol. So we're still in the mode where we're choosing a symbols. So I'll just click again, and we want to put another LED. So let's pick out another thing. We need to add a resistor. And for that, it's such a common part. You can just click R, and that is a common term for a resistor. So we'll throw that on there. We want a battery source. Battery. It has the recently used up here because I've just set it up earlier, but you can see here, like typically you would see this, there's this battery and this one here. This one is actually multiple cells, as you can see by it, but we just want a single cell, so we'll just click on the battery cell, double click, and then set that. I want to go ahead and put a switch on there also, so we'll, switch. And let's see. And for this, I know that I want to do a 3-part switch. You can see some of these that down here, it shows a preview of what the footprint might look like, because some of these schematic symbols, they're for a specific footprint, and it has one already assigned to it. But that's not for everything. So I know that this is what I want, just like a simple little slide switch to turn it on and off. So I'm just going to choose this component and place it here. I'm going to hit escape so that way I go back to just a regular pointer. And now we have all of the parts on the screen that we need. So we can go ahead and start wiring it up. And for these, whenever you wire it up, that will let it know that this is where it needs to be connected electrically. And so for this, I know that I want the switch to go in between the battery cell. The LEDs are wired up together. We'll throw that on there. We'll wire that up to one side of the switch, so when you toggle it, it'll connect power or disconnect it. And for this, we can connect this here. And that is the ground side of the battery. And that hooks up to the negative side of the LED, and the positive side connects to the positive. Not sure why that one looks, just for our sake, let's make that look exactly the same. One thing to note, that a popular thing you can do is you can use like a ground symbol or a power symbol. Ground is so common in electrical circuits. It's very common for everything to tie back to ground within a circuit. It's so common that they have a ground symbol for it. And so wherever you put that ground symbol, then this will be connected on the PCB side for it. So you can either draw a ground wire to connect it together, or you can use symbols like this to let it know that anywhere that it sees that, those will all be connected together in the final product. So I'll just leave it like this because this works as well. Let's go ahead and save it. And I'm going to go ahead and just delete this, just so that way there's not duplicates on here. And now we have these parts on here, but we don't know what kind of footprint this is. To get to this, I just double-clicked on that part. And so for each schematic symbol, there is, the reference for it, value, footprint. You can attach a data sheet to it, description, all of that. But we want to go through and tell it what footprints we're going to use, what parts we're going to use. And so you can do that one at a time if you want to, but there's also a tool up here, and this is the Assign Footprint tool, where you can do all of them at the same time.
Sorry, what is footprint?
So footprint is like the actual, all of these are footprints on here, and that footprint matches the pinout of the part that you're sticking on there. So that way, yeah, like the physical dimensions for it. So for this battery connector, the footprint for it was this pattern that had the two holes that matched up with the battery terminals that came down. And so for all of these components, they all have a unique footprint that is assigned to it. And so now it's a matter of figuring out what part do you have or what are you ordering, and make sure that it matches up with the footprint that you assigned to it. And I'll show more about that as well. And so for the battery cell, I know that I want to use a coin cell for it. The common coin cell is a 2032. It's you might have seen the standard's about that big. And that is a 20 millimeter coin cell. So we just type in CR20. And in this window, there's this with a little magnifying glass on it. I recommend clicking on that, because then when you go through and look at this, you can see what that footprint looks like, and it makes it so much easier. So I want to use...
Those are all different footprints for the same battery.
Yeah, these are all for, right now it's just filtered by anything that has CR20, so for any 20 millimeter battery, which is typically going to be 2032. Sometimes there's this CR2025, but I just typed in CR20, so we could even do 2032, and that'll filter it a little bit more. And so, yeah.
These, how do you know which one you want? How do you pick?
Which one you buy?
Yeah, and I'm going to pull up I'll just pull it up now, I'll show it to you. For this, I happen to know that I want this one on there. I picked it out earlier, and I know that because I went through and searched for the part that I wanted. LCSC is like one of the biggest suppliers of components that is accessible to us. They're based in Shenzhen, China. And so this is like if you get into production level stuff and you need to find parts for a good price, LCSC is kind of the place to go. If you're just getting started, this is like this, and even like Mauser and DigiKey and stuff like that, it's just like an insane catalog of parts to dig through, and it can be really annoying.
I can have a set standard of which comes built into the footprints that's in the list, so you don't have to like go find make stuff.
Not for everything, but they do have a standard, but I'll show you why this is also kind of a thing. So I'm gonna click on the footprint, I'll just edit that one individually. We're just doing R. So THT is through hole, and so this, you can see there are a bajillion resistors to choose from. Like, there's hundreds of them. So it really is good to, in the beginning, to kind of narrow down what it is that what you want. And so for me, I have my own library of parts that I commonly use. There's like a different one.
You find the parts first, and then given those parts, you create the...
Ideally, yeah. You probably want to pick out the components first and then get the footprint to match it.
Okay.
That's usually what I do for it. And so LCSC is like the biggest catalog for this, but even if you are starting out, like you could go to like SparkFun or Adafruit or something. We'll just look at Adafruit. Let's see if they have resistors. So they have like, these are some of the most basic resistors, these quarter watts. And don't know if they do. They've got a data sheet. And here, there's all this stuff in the data sheet, but then it will usually show, I hope this one shows it. It shows like the lengths and the width and the height of everything. And so from this, we know that this pitch will define like what the pin spacing is supposed to be for it. And so we would go through and like pick out the dimensions like that. And I will also say that there are additional libraries that you can install that are made to specifically solve this problem of there being so many parts. Within Kicad, there's the plugin content manager down there, and there are some libraries in here that narrow down the number of parts that you have to dig through. I can't remember which one it is specifically, because I've got my own kind of, I've just been in it for so long, you know. But which one is it? Parts. This is, yeah, it's from one of these. I'll find the right name for it afterwards, but for the workshop purpose, I'm giving you the name of the footprints that you need to find. So we'll problem solve that a bit later. But so typically, like, I will go and pick out the part that I want. I'll usually go and find it from an easier to source website first, and then search for that part number on LCSC where I can source it for much cheaper. And so for this one, I know that that is the part that I want. It has a data sheet that I pulled up the tab for, and so this kind of tells me the dimensions for everything for mounting it. A lot of these have the pin on there, but I know that this one, there's the surface mount version of it. And that's the minimum for it. It's really just making sure that pin spacing is accurate for it. Let's see, so I'll go back to this. And so I know that for that one, that this footprint will work for that part. For the LED, let's see, you can do LED. There's a bunch of filtered ones on here. Usually they'll break it down by SMD or THT. THT is a little bit easier because there's, for through-hole LEDs, there's typically 3 millimeters. For the smaller ones, 5 millimeters is this common size that you always see. So you can kind of filter it down by that. For this example, I'm going to show surface mount ones for it because essentially, like, surface mount stuff seems like a little bit scary and harder to work with, but the parts are much cheaper, and once you know how to solder them on, it can be really quite easy to work with. You just need a pair of tweezers in order to like hold the part while you're doing it, and I can show my graphics from a soldering workshop that I teach that shows it in just one slide, like how to do it. But it's really nice if you're going to use it for any small like wearable design, because then it's not big and chunky and getting in the way. And so for this, I'm going to do let's see. I want to do a 1206 LED, which is one of the larger footprints for surface mount. There's typically 1206, 0805, 0603, 0402, 0201. And 0201 is like tiny. But so 1206 is a common biggest size. And so I'm going to pick out a 1206. And I filtered it by that. You can also filter by where is this? By the pin count. Also, one of these buttons here, these are like further layers of filtering it. So since the LED only has 2 pins, we can filter it by that to further reduce the list of things that it shows. And so I want to do a 1206 LED and reverse mount. These have holes, pads. Let's just do a standard reverse mount. Typically for every surface mount component, there's like this one here, but then there's usually ones that say hand solder on it, and that means that the pads are just a little bit longer to make it easier to work with by hand. So I'm always going to pick out the hand solder ones. We'll double click on that.
Part's the same, right?
It's the same.
It's like more clearance or something?
Totally, yeah. It just has a little bit more clearance, so the pad's just a little bit bigger, so it's easier to work with.
Under the sign footprints, where do you find the graphics? Like, how do you get the graphic to pop up?
This little icon up here with the magnifying glass on it.
Oh, I see it. But it's like delayed here, by the way, so by the time I look at it, we look at it, so it's 16 seconds, like I see.
Yeah. So I'm going to double click that again. And so for this resistor, let's click on restore. Will it let me do that? Resistor SMD. You can see there's 0201, 0402, 0603, 0805. We want to do 1206. So I'm going to get that one with the hand solder again. Double click on that.
Does the software validate correctness? Like if you pick a resistor that's like way too big, does it flag it as so it doesn't validate anything. You can do it whatever you want, basically.
Yeah, you can give it any footprint that you want.
Okay.
So you will just want to double check it later on by typically looking at the data sheet for the part. Like I had here, like for every single part that you find, it's going to have a data sheet attached to it that will tell you all the dimensions for it.
Okay.
And so for the switch, I want to use this switch here, which is a pretty common surface mount switch. It's nice and small. And so this is the data sheet for that. And this one is just a 1-page data sheet that tells you all the dimensions, and this shows the footprint of what that is supposed to look like. So it can be a little tedious, but like once you have the family of parts that you like to work with, then you can reuse that for future stuff, and it makes it easier. So for this, this is the data sheet. I have pre-validated this before doing this. And so the switch, let's see, this is I can find it. It's not. let me take that off. Unswitch keyboard, SMD, dip, push button. So these are all button switches. Relay, let's try slide. Those are all slide switches. And this is just like a giant array. Here we go. Just bypass all of that, because usually there'll be banks like this where it's just like adds like 1, 2, 3, 4, 5 or something. So you just bypass that whole chunk there and keep looking. So this is the switch that I want, and this matches the footprint for this. I also have this saved in my personal library, just so that way it's easy reference in the future. But so I know that I want that switch. Did it take it? There we go. And so now all of my schematic symbols have a footprint assigned to it. So now we're back to this, and you can see when I double click, there is now a footprint assigned to each one. There's no footprint for ground because that is just a power symbol that lets it know that anything with the ground symbol is connected. So I'm going to save my work. Save often with this. Kicad crashes sometimes. But now we can go over to the PCB view and start laying out the PCB. And so we're going to click on the switch.
What view is this if not the PCB?
Huh?
What view is this if not the PCB?
So this is the schematic view, and so this is like the drawing of what we want to have wired up for it, and we've assigned footprints to these parts, but this is just the symbols that represent what it is that we're working with.
So then we see the ground and everything properly.
Yeah, so now whenever we click on this symbol here, we'll switch over to the PCB editor. I deleted everything earlier, so I'd have a nice blank screen for this. There's a button up here, and this is update the PCB from the schematic because they're interlinked. So we click that. I'm gonna update the PCB and close, and then it drops all of my parts onto the board. And so now these are all the parts that I assigned, and it just kind of groups them together. So now we can move these around and set up the board how we want. And you notice it has those blue teal colored lines that are on there. Those are rat's nest lines is what they're actually called. And so those are, it's linked in a way that Kicad will always remember that these are supposed to be connected, but you haven't laid out the physical wire yet. This is just letting you know that that's ultimately where it needs to connect. And it can be helpful because when you're laying it out, a lot of times people will want to keep their lines nice and short, depending on what they're doing. So then you can go through and lay out everything where you want based off of the links of it. So you can get it nice and tidy. You can be very OCD about this. It's very satisfying. But it's good to know this because it would be a little bit more silly to have stuff kind of all over the place, because then you would have wire traces, going everywhere for it.
Does it have like an auto button to kind of like put it in a grid for you automatically and kind of keep it organized?
There is a shortcut button for it. I don't remember it off the top of my head, but there is a thing that will kind of like lay it out as a grid.
Or just like do it all for you, like figure out the best, most efficient way.
Yeah, there is also an auto routing feature in Kicad, and it's funny that like in 2026 it's still not very good, So it is like even today, even in this modern age, most people working with circuit boards will insist on doing it by hand still. But there are some shortcuts for this that I can show you.
So the layout is the main consideration, just like how messy you can get.
Yeah, and especially if you're working with like a microcontroller or high-speed data lines, some of those, it's like very important for it to be really short. Oh, hey Joey. Hey, Jar. Welcome. So yeah, depending on what you're working with, sometimes that could be really important for the lengths of the cables for it, or the wires. Welcome. Welcome. So, we've got the schematic. We did the schematic. We assigned the footprints. Now we're in the footprint editor. We've got rat's nets. We've got everything set up. But for this, part of this workshop is that we want to make it look really cool. So we're going to this is going to be a bit of a side quest, and we're going to come back to this. Because for this, like, we can put this together and just do like a boring PCB if we wanted to, but we want it to look cool. But just for all intents, just for real quick, just to show, I clicked on this box icon over there. You could, if you wanted to, just draw a box. And this happens to be assigned to edge cuts because I had already highlighted. You could change that around and assign it to something different. So that could be a front copper trace there. It could be something else. It could be a silkscreen outline. But we want to assign it to the edge cuts file just for this example, and that tells the fab house where they want to cut the board out. So for any PCB that you're looking at, that border where it has been cut out is because of the edge cuts file for it. And while I'm here, I guess I'll talk a little bit about what I'm looking at. I like having this properties window open, and I got that by doing view panels properties, and so I have that checked. And I also have the appearance window open, which is the one that's on the right over here, and that's usually open by default. But this shows all of the layers that goes into a circuit board. Not everything is being used for it, but we've got the front copper, which is all the stuff in red. There's nothing on the back yet, but if there was, it would be blue. Front silk screen, which is going to be like some of the text for it. Like this right here, the text for this is on the front silk screen, back mask, and a bunch of other stuff that you don't really need to worry about. This selection filter is also really helpful too. Like if you're just wanting to select things and it keeps on, you know, like if I click this, it doesn't know if I'm trying to select the pad or the whole footprint. So if you're doing a bunch of stuff, you can change this so that way it only selects, say, just the footprints if you're moving it around. But with this, it's not wired up yet, but we have the edge cuts on there, so we could open up the 3D viewer panel and get a preview of what this would look like. And so for some of these parts, for the LEDs and the resistor and the switch, this already has a 3D model assigned to it in the library. This one doesn't, but you could fix that if you wanted to. I usually don't worry about it, just for something like this. But so this is really helpful for going back and forth to confirm that everything is where you want it. And so it's very common, like I'll end up opening that up quite a bit. And something to show with this too is that for this, like I mentioned, these are linked. So if I click on that, that highlights that part there. If I click on that, that highlights that. So these are all linked together. But it's important to know that if you make any changes here, you would need to then update your schematic based off of the changes that you made in the PCB. Because if you are then going back to the schematic and then you update your PCB from the schematic, then it'll try to revert back to what was happening there. So it's important to remember that they are linked and to make sure you update one against the other. Because you'll find as you're working with circuit design, there's going to be a bunch of back and forth with it typically. Okay, so now we're at the point, we've got our schematic. We've got the PCB set up for it. We've got the footprints assigned for everything. The rat's nests are hanging out, reminding us how all of this is supposed to be wired up. But we want for this to look cool. We don't just want a weird square outline that's boring. So we're going to segue into a totally other chunk here. And this is going to be about setting up the PCB with custom graphics. And so for this workshop, I'll show you a link for it. I have slides for this, but I don't know if I should go through the slides for this or not. I don't know. Maybe I will. I'll show it real quick. Let's see. For the graphics for it, I'll give you this, just so you have this. And this contains a bunch of pre-done graphics in there that I already did if you just want something to experiment with, and it's what I'm going to be using for the example for this. But I will segue and just kind of show. These are examples of circuit boards that I've experimented with and made, and all of these were done by hacking the layers of the circuit board. So the hack one there, I have that one here. It's got the graphics on the back side of it. But for hacking the circuit board for artistic purposes, the fab house doesn't care what you put on your board. They're going to charge you the same no matter what. You know, if you do a bunch of complicated cuts and you get, add a bunch of things that require extra drilling processes and things, maybe it'll adjust the price, but for the most part, this doesn't change the price of it by adding cool graphics on it. Whether this was just blank or had a bunch of art on it, it's the same cost either way. So I really like using it as a creative medium just because it's got really fine detail to it and it's repeatable. And so I like working with PCBs because you put in a lot of work up front to get it exactly how you want it. And then once it's done, you have the file saved and you can order 5, 10, 50, 100, 500, however many you want. So in terms as like a creative output, if you're trying to make products to sell or whatever it is you're trying to do, I find it more sustainable from an artist trying to survive in this world, and so it's fun. Like I was talking with somebody earlier, we were talking about how we were wanting to do like an installation-based piece, and we were talking about how we could figure out how to do one small like interactive tile for an installation piece, and if we did it that way, then we just make one thing and then replicate that, and that could become a much larger installation thing. So there's a lot of fun ways to work with it. But so this shows just some examples for what you can make. I could share the slides also. There's a bunch of really awesome work out there in the world. There's tons of creative designers out there. It's all super inspiring, so definitely check it all out. With the circuit board that we're working with, this just kind of shows the layers of a double-sided 2-layer circuit board. And every single one of these layers can be hacked for artistic purposes. So you can assign custom graphics to all of this. You could do custom cuts out of the fiberglass layer. Or for this one, I deleted the solder mask off of both sides, so the light on the back glows through, and it just happens to make a really good diffusing layer for making cool graphics. And it's much more pleasant than having a bright hot point of light pointing at you, so please diffuse your LEDs. It's like better for everybody, and it just looks cool. And so like for this one, this was just like the bare, this has the solder finish on it put on by the fab house. This one that somebody made, they didn't even put that finish on there, they just left the bare copper that the fab house produces. And so yeah, there's different ways of doing it. You can get different colors with things. These are the common colors that you get from the fab house. And so somebody made these color swatches kind of showing the color palette that you can work with. If you want to get really nerdy about it, you can set up your hex color codes in your whatever graphic design software you're using. But usually like for this or anything else, I just went and like did like the eyedropper screen grab and grabbed an approximate color. And that kind of helped me whenever I was designing it, just to kind of remember what it would look like. And so I did that with this whenever I was designing this one here. This one is very small.
Did they dye the gold wiring?
The what?
Just the gold wiring and the underlying.
There are only a couple things you can do. So this is the bare copper. They can do a silver finish on it. And so this, I use a lead-free finish on mine because I'm very adamant about being anti-lead. not anti, I'm adamant about providing things that don't poison people with lead. We'll say it that way. You can also do an Enig finish, which is a gold-plated finish, and that's what's on these. It doesn't look too terribly different, but the Enig finish, solder sticks to it really well, and so it's a much better surface to solder onto, but it tends to be more expensive. So I don't always use that.
But you can't make it like pink or like something.
Not for the copper layer, but they can for the solder mask layer. And so these are the typical ones that the fab houses will do and what they'll provide, but there are some factories that are starting to come out with custom colors. They have a broader range of options. And if you're doing a really big production run, you can talk to some of the factories and they can custom mix up a bucket of solder mask for you. But you typically would be needing to do a higher volume for them to be willing to make modifications to their process. But it's becoming more and more like in demand as people want to do cool stuff. So you are starting to see it more and more. There's also some artists who they've convinced the factory to do a 2-color solder mask where they ran it through the machine twice with 2 different colors. And that's pretty cool too. But with that, just within the past couple of years, they've started to come out with the ability to do multicolor. This is an example of one of the multicolor ones. And this is a UV printing process. This had I think I did the Enig finish on this, so this was like the gold-plated finish. But they'll do a full color print on there. And so this was just a graphic image that I sent them. You can see here, this is like another thing that I made that I took some close-up photos of it. But this I wanted to show to people because it looks really awesome, but it doesn't have as fine detail as the silkscreen layer does. So this kind of shows that the text is clearer here versus how it looks with the multicolor silkscreen. You lose some detail, so you just kind of want to be aware of it. And I could have chosen a better color contrast too. That's not helping the situation at all. But it is like, you can kind of see it's like not as clear. Because I asked them whenever I was doing it if I could put, if I should put a silkscreen layer on top of it, and they were like, no, the whole thing is your multicolor silkscreen, so there is no additional silkscreen layer of text on top of it. It all becomes one file at that point. And so there are a couple of ways that you can bring in the art, but instead of making you look at slides, I'm just going to do it in front of you and show you, because I think that's more exciting. So in Affinity, I set this graphic up here. Previously, it was some thing that I just like took off of, I don't know, whatever. I recommend what's the one, like Shutterstock or something like that? Just take the art, just use it, it's fine. Nobody cares. And so for this one, I took this random cat that I found, and I converted it into this halftone effect. Let me see if I can do that for this one just to show. There's a view filter, filters, distort. I can't remember which one it is. I gotta look at my own slides to remember where it is, but there is a halftone setting that you can do on there that you can add this halftone effect. But I'll share the slides with you. You can see it later. But I like doing this because then I can import that halftone look as a top silkscreen layer, and it will retain all of that detail, because the silkscreen layer, when you're doing a traditional PCB, it can't do gradients. It's just all, there or not. It's typically opaque. And so by using different kind of halftone effects or like a newsprint effect, you can emulate depth with it. And so that's what I was doing with that. So it looks like it has depth, but it's just a solid black and white color. And so for this, you could bring this in as individual files if you wanted to. And I'll show you that really quick just so you can see how. There's two ways to do it. If you just have a graphic image and you just want to bring in a photo or something, you don't want to mess with design software, you can just click on this image converter tool here, and this will, let me see, this will pull something in. What do we have? Do I have a photo? We could be cringe. We'll just use a photo of myself because that's what popped up first. So that's what we got. It's probably massive. It's absolutely massive. There's a giant picture of my face. So, you know, but that's kind of cool. I don't know. It looks kind of awesome. You can change that. Say maybe we want that to be like 75 millimeters tall. That will be the output size for it. But for this one, we're stuck seeing this giant one. But you can play with the threshold of this, and then that will change what the end result is going to be. And so this is like a quick and dirty way of getting an image onto your PCB. And then even from here, you can export it to your clipboard. So now it's saved on your clipboard. And then here, you could just paste it. Oh. That was a PNG, huh. Well, oh, you know why? It's because it's a giant image and it's still thinking I had like a different thing. Did I just save it? Let me try it again. I might crash out Kicad doing this. And that is the thing, save often because it gets really grumpy when it will let you try things that you shouldn't do, like this. Oh, there we go. And so this is kind of crazy looking. That looks pretty wild. But, you know, that's cool. We could hit F, maybe let's flip that to the backside. Oh, I know why. It's because this has a really high pixel density or like a vector density to it. So what I should have done is shrunk the image down first and then brought it into the graphic thing to change it because by working with such a large file first, then it is, yeah, there's just way too much data built into this. And so even though I exported it smaller, it still is compressed with way too much gunk. So yeah, we'll just let that do its thing for a little bit. We're gonna go back over here for a while.
What like DPI would you recommend for like, because obviously like it's not even on the silk screen, but like what usually works?
So for the DPI, this is the next tool that I'll show y'all. So I'll go ahead and pull that up now. I really like this tool called Gingerbread. And I have slides about it, but you can also just go and read her docs. She tells you everything that she recommends for setting up a page, and she uses this 2540 DPI because it matches this 100 dots per millimeter, which is like helpful with particular routing issues and whatnot. So she recommends cranking it up to 2540, and then the dimensions, it should match what it is for the size of the board that you're going for. And so for this, previously, I went in, based off of the instructions in that doc, I assigned this, or I labeled it as the layers that I want this to ultimately end up as. So we've got our edge cuts, front silk layer, silk screen layer, front mask and back mask, because I want to delete the solder masks for the eyes so we can put LEDs on the back and we have some glowing cat eyes as a result. And so I did this earlier, and I saved it. Is it still grumpy? Yeah, it's still grumpy. It means that we'll go hang out over here. And then here, I saved this already, so we can just drop this into Gingerbread, and it automatically recognizes those layers, and it gives you a preview of what it's going to look like. And you can even play with the color for it if you really want to, and see the mask opacity. Some fab houses you can use different silk screen colors, but it's typically white is the common one that you're going to get. It also, there's a 2540 DPI, and then the dimensions for it. And then same thing here, you can just copy it to a clipboard, and it's there. And this is mad about me doing that, so I might just have to like force quit this real quick because I managed to break it, which is a good example. Like this is totally what happens sometimes. And how do I force quit? I think it's like this. It's like it's so common with the Mac that it's like a shortcut up there. So we're gonna force quit Kicad because I don't want to wait on it. And then we're gonna open it back up. Where is Kicad? There we go. Now let's see when the last time was that I saved my board. No, I don't want to open the auto-saved file because it'll get stuck again. And look at that, that's great. There's nothing there because I didn't hit save on the PCB editor. But because we have it saved in the schematic view and we didn't do anything over here yet, I'm just gonna do update from the schematic. No, because I did save that one already. Okay, so we'll update the PCB, close, and then there we go. So now we're back to this point. We've got our parts ready to go, and we can start spreading this around. And also, let's see if I still have that on the clipboard. Paste. Now we have our graphics in here. And so this is a multi-layer thing. We're gonna go to View, Properties. And so for that, I just highlighted the edge cuts layer. I'm gonna make this smaller. It likes to pull it in really big. So now we'll just make that a smaller line. This is the front silkscreen layer, and then it has, this is the front and the back mask layer for it. And so if we view this in Kicad, I'm sorry, in the 3D viewer, it always defaults to the edge cuts, so anything outside of that has been cut off. So now this is a preview of the mask layer for it. Oh no, are they still? Oh, they're still floating in space over there. But when you send it to the fab house, that's all that they'll see is the edge cuts. So now this is set up, and we have a foundation for adding some parts onto. And so just for the sake of being able to see stuff, I'm going to hide the front silkscreen layer so we don't have to work with that. So this is our battery. You hit R to rotate, and we can start sticking this on there. I think that it's this side. Put that there. Say we want to have a switch, we'll pull that over, decide where we want that to be. Maybe we want it.
Will the traces stay straight lines? I thought they should be like 90 degrees or something, right?
Yes, the traces will change. Right now they're just rat's nests, so it's a representation of where the parts are connected, but there is no wire or there is no copper traced for it yet. So we're still in the stage where we are just setting up where everything goes. Maybe we'll put this switch. No, it's a little bit too tight. I'll leave it up there. So first we'll figure out where we want everything to go. Put an LED over that eye. And then grab that one too. We'll zoom in. And I can do Shift R and to go back and forth with it. So Shift R. Oops. And then we'll line this up there. And now if you view that in the 3D viewer, then you can see that the LEDs are lined up, everything's where you want it, and then when those LEDs are illuminated, it'll glow through on the front side. Yeah. And it's mildly transparent, so you can kind of see the back of the LED shining through it, which is kind of cool. Yeah, so you'll be jumping back and forth between the 3D viewer and the PCB editor a lot. Now that I have this, I'm gonna hit save, and now this is locked in. Okay, and so now, let's see, is this where we want it? this works out okay. Maybe we want this like a little bit over here. Maybe we want it up here. That's up to you where you want that to be, because we've got the little switch, so I don't want it to be buried too much. So that's kind of a nice spot there. Let's see. And there is, I see how that is a thing. That's fine. Let's throw that there. If you know that you're hand assembling stuff, give yourself room to get in there with the soldering iron. So just keep that in mind. But now that we've got the parts where we want them to be, maybe let's pull that away just a little bit so it's not grumpy. It's gonna get grumpy that this pink outline here, this is the courtyard, which is kind of just like a border, a boundary, so that way you don't put parts too close to something else. See how it turns red when you get over there? It's just a boundary thing letting you know. And so it'll probably throw an error that this is going over the edge cuts, but it's okay. You can break some rules. It's fine. So I'll just leave it like that because I really want it to be on the eye. But now that we have this here, we're ready to start laying out some traces. And so this is the wire button here. Oh, one thing I just remembered. Right now we have, this is a front silkscreen layer. But we also have these parts on the front layer. So we don't want the silkscreen art layer on the same side as that. So before I forget, we are going to change that. Because it's a weird graphic, I don't know. See if this will let me do it here. I'm gonna try to swap it to the back silkscreen layer. I don't think that that did it. View. It gets a little funny working with graphics. So I'm gonna be lazy about it. We're gonna select the footprint, hit flip, now it's on the back side. We're just gonna move the parts to the back side. Do you see what I'm trying to do, Joey?
Yeah.
It's.
I think you can flip it to the backside and then mirror it, and I think it'll work.
That's what I was thinking. It's funny though, because like.
Oh, weird. You did change that. What did you hit F? And then.
Now it's over there. Oh, and then I.
Then you can mirror like when you. Edit.
Under properties?
Yeah. Check off mirror, or can you not mirror?
Edit the.
Oh no, I guess you can't mirror. Okay, yeah, I guess.
Yeah, it's a little funky. Yeah, and like I said, everything can be customized in Kicad. But it's a pain in the butt working with graphics like this because it thinks these are all individual, vector lines, and you can't grab a group of vector lines. You can only edit it one point at a time, which is why we do all of our graphics outside of Kicad and just bring it in when we're done. So yeah, I'm gonna just undo, leave it like that. We're just gonna, yeah,
Look at all of that.
Just flip that over. Not that. Uncheck all that, click on that, turn that off. Click on that, flip, 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 and just rotate it. This is something too, like whenever I was in Gingerbread, I could have assigned that here or here. Ideally here, I would have just put that on the back silks layer from the get-go. But as you can see, there's all sorts of ways to cut it. Okay, so now this is on the back side. Silks are on the front. Go to the 3D viewer, and now this is how we want it. Now we got our parts on the back and the cool graphics on the front. And so now we're ready to start laying out the copper traces for it. Almost. Rotate some of those parts. Let's see, this is, I'm gonna put this here because you can see how those wires cross over there. So just for the sake of this, I'm just gonna put that there so I don't have to deal with that.
Makes it easier when the air wires don't cross each other, so you don't have to like zigzag around things.
Yes. And so for this, now we can start laying out the traces for it. So I'll just click on that. And because it has the rat's nest or the air wires there, it knows that these two parts are supposed to be connected, and it will not, intuitively, it will not let me connect it to anything else. So it's got your sanity check kind of built in there to make sure that this gets wired up how you want, because once it gets more complicated, it would be very hard to do it outside of having a schematic. I'll double click to end, and now that is a copper trace. You can see it in the 3D viewer. Turn off the back mask. There, you can see that copper trace there. And then that's like the back silk screen. It's the common parts that just kind of show where everything goes. And you can always delete that too if you want to. I typically will get rid of it. Like, I don't need to know that this is BT2. It's fine. Okay, so for this, we'll wire those two up. Oops, double click. That. It also doesn't want for you to go across the edge cuts. And let's see, I might not have left enough room here, so it's going to get grumpy. So cancel that. Just to make this easier, we're going to scooch that back just a little bit. And you could do other tricks. Will that let me go through? Now it'll do it. If you ever need to jump over stuff, you can add vias, which are little tiny holes that go through the board so the trace can jump to the other side of the board and back. And you just do V, oops. And you can see that is a via. It's acting very grumpy because it's close to other stuff around there.
Is there a downside to vias? Like, I can just easily jump over any other wires?
They're usually okay. It's just, again, like if you're dealing with something that maybe there's high-speed digital signals or something where you have to be really careful about interference, you might not want to put a via. Or if you have art on the front, like this will create a tiny little divot on the front, but it's usually pretty well hidden. Like even this, you can't really tell so much. So it's just kind of a personal preference. It's more like how OCD are you, you know, and like how careful you want to be. But even this, I could be lazy and just throw a via in this pad, which probably makes some people cringe, but that is totally okay. But I'm not going to do that. So we're doing stuff on the back, so click that, draw that down, and we want that to connect to ground. There we go. So now that trace goes there. I do get grumpy about these traces being too close. Oh, I have this filter still turned on. I want to be able to select the tracks. There we go. Now I can pull that track. I'm going to just pull that away. You can kind of adjust stuff, and you see, like, it lets you know, like, you can't get too close to the edge cuts. You can change those preferences so you can, you know, break the rules a little bit more, but I recommend not for that. There's reasons that they have those tolerances built in. I think even the way that I have my traces set up is kind of my own custom thing as well, that I'm able to do the free angle bending for it. But it's not too different from how anybody else would experience. Oops. So that, we're going to highlight and drop that there and drop that one there. And see, it'll also push tracks out of the way. So if you have a bunch of traces on your board, it makes it a lot easier to lay stuff out. So then throw that there. And this really wants for these to be connected, even though this is a giant piece of metal that connects it over it. It doesn't know that. So I'm not actually worried about that. So now this has everything on there. I'm going to save my work. And let's view it in the 3D viewer just for a sanity check. Flip it over. You can see all the traces there. And so now I probably want to kind of clean up this silk screen labeling on the back of it, just so it's not too junky. And I think even this kind of represents how the battery holder would be soldered on there. So I think that would be the back side, so you'd insert it on that side. And so then that's up to you, like if you want for it to represent that, you would insert the battery this way or that way, but for this particular case, since there's nothing here, that's okay. But I do want to, oh, see, I've got to be able to select that. Let's turn it on so we can select everything. So now we can select that. Let's see, how do we edit? We're going to do a fun thing. I think the Kicad font is boring. I like changing the font. I think it's just like an easy thing that you can do. And so there's a million different types of font on there that you can do. The one that I like is, where is it? Metal Gear Solid 2. Apply that to everything. Oh, but then does it do it? Let me try it again. Edit, text and graphics. Oh, we want to change, here we go, my bad. We want to change the reference designators, values, PCB graphics, or sorry, text items. Footprint, yeah, just select all that, it's fine. It's gonna be one of those, I can't remember which one. So we're gonna change that back to Metal Gear now. Apply and close. And now, then this is like a slightly different font, and I just think it looks a little bit better. It's just more interesting to see. And so,
by convention, do you have to keep the reference text, or can you just remove them all?
you could just remove it entirely if you wanted to. It doesn't have to be there. And a lot of times, like if it's super simple like this, I might remove it. But if you're giving this kit to somebody else to put together, it's good to, you know, give them a couple hints. And you can even see for the LEDs, LEDs are polarized, so you want to put it in, it has like a positive side and a negative side. So this is an indicator to let you know which direction it should go. And so, yeah, we'll just leave that on there, that's fine. We've moved that to somewhere that's visible, save our work. And in theory, this is a circuit board that we can order. But before you order a board, I always recommend you want to use some of the built-in sanity check tools to make sure that you've wired everything up. Because once you get a complex board, it's super easy to forget, you know, that something hasn't been wired yet. So we're going to use this thing called the design rule checker. I'm going to run the tool, and then what that does is that then it highlights all of these arrows, letting it know where it's either seen errors or warnings or anything like that. And so there's a couple of different things. We've got errors, all the yellow indicators are warnings, but because when you're doing custom graphics, you're gonna break a lot of rules and it's gonna make Kicad mad, and so don't pay attention to the warnings as much, but do be aware. Like here, since this is on the back side here, it's not so bad, but in theory, I should move this pad down a little bit, or the whole footprint down, so that way it's not going over that spot there. It's not the end of the world. You know, it's doing it here too, but it's fine. It's on the back side, so I'm not too worried about it. It'll get grumpy about here, and you can like highlight it and it'll tell you what it is. Silk screen clipped by board edge. It's fine, no worries. Same thing here, that's probably another one. Silk screen clipped by board edge, that's okay. The things we really care about are the errors. And so that is yelling about board edge clearance violation, polygon on the edge cuts. And so that is this. It's getting grumpy that it's too close to the edge cuts. It's okay, it's, you know, not the best, but it's okay for it.
Throw a note in.
Yes.
That, it's like these are like rules that like the PCB fabrication house says about like how close it can be to the edge to fabricate correctly. A lot of times
Yeah.
if you send them something like this, they'll just trim a little bit of it off.
Yeah.
Fine. Like
Yeah.
they know what they're doing, and unless it's like pretty egregious, like some of the errors like this that you know, like Darcy knows what they're doing, like it's easy to, yeah.
Yeah. Yeah, so it'll be okay. They might get grumpy if they're doing in-house assembly for you.
Okay, yeah, that's true.
That could be a thing. But if you're doing hand assembly with this, you can break the rules all you want. it's all good. So same thing here, it is board edge clearance, that this is too close to that. So in theory, we're gonna be good about this. We're gonna do that. And I usually will change the rotation angle of how much a part rotates. So right now it's like maybe like a 5-10% rotation step, but you can change that and fine tune it so you can really dial in a part. So let's what if we do that? Then we can inspect, design rule checker, delete all the markers, and then run it again. And now we just have one, and it is the back mask polygon right here. It's getting grumpy about that it's touching there and there. But that's okay, we're not too worried about that, so that is totally fine. I'm gonna say this is good. And those indicate the arrows on there. If you want to, you can always just delete all those if you don't want to look at it anymore. So now we've got a nice clean board. So now we're at the point that we can order this. Save it. And in order to order this, we're gonna produce a bunch of files that are called the Gerber files, and that is what the fab house wants. And that lets them know the edge cut, where to cut it out. It lets them know where the drill files are, what the silk screen layer should look like, the solder mask layer. It gives them all of the defining parameters that they need for every step of the process. And we do that by going up to File, Fabrication Outputs, Gerbers. And so this, by default, this stuff is going to be checked. You don't have to mess with this too much. This already has all of the information needed for the parts that you have on your board. So it's going to give them the front copper, back copper. There's paste layers. You actually don't really need the paste layers. I just leave it on anyways, it's fine. Front silk, back silk, front mask, back mask, edge cuts. Let's see, sometimes I like to click the subtract solder mask from silk screen, but the fab house will do that for you automatically. So then we can do plot. Where did it save it? Oh, I see. And then we're gonna do generate drill files. And I just leave this, I don't change anything, I just hit generate. And then we go close. And now that is going to be in documents. Where is GitHub? TRC3P. Oh. And what today? Kicad Speedrun. So now all of those files are in here. And so this is also where like the master file is for Kicad. This. And so we can see all those files that were produced also show up in this hierarchy here. There's like a Gerber viewer if you want to view the Gerbers that you just created. That's all good. I usually just filter it by the time for it, of when it was modified. You can highlight all of that. It was all made at the same time. And that's front, back, paste, silk screen, mask, edge cuts, Gerber job thing, plated, non-plated, drill files. We're going to compress this, rename that Kicad Speedrun Gerbers, or whatever file you want. And so now these are our Gerber files, and we can order these, and I'll show you that process real quick.
Do any fab houses support just the Kicad files and just send them your save file?
They do not. They do not. You always got to make the Gerbers for it.
And the drills.
And the drill files, yes.
2 separate steps, which is annoying.
Totally. Yeah, I don't know why it's not just the same. And so if you're ordering your first circuit board, there is a local company based in Chicago that I really recommend. They're called Osh Park.
Portland, right?
They are Portland, but they are, oh shit, you're totally right.
It's always,
No.
I've always lived in Portland.
I always get confused because Drew used to live in Chicago, so my bad. Anyways, they're based in Portland. You're right, they're in Lake Oswego. I've been there before. Sorry, long day. So Osh Park is really awesome for ordering your first boards. It's, they They provide like really good specs for their default board. They only do purple PCBs, and but it's always Enig plating. It's got this nice thick finish to it, but they do offer like this after dark option, which has like a clear solder mask on it. I wish that they had some visuals on there. Yeah, it's a clear solder mask on a black substrate, so it makes it very stylish. It looks really cool. So all the copper traces and stuff would be very clearly exposed. But I really recommend these folks for your first design that you do, just because they're really awesome to work with. And so we're gonna go
After
to.
dark. This is a good one.
Oh, you got a photo of it?
This is the purple on the one side and the after dark on the other.
Oh, nice.
So
Yeah.
it's like the copper color, but also the gold color, and it's black in the background.
3 copies
Is
from
that not populated as parts, or is it just?
This is just an art PCB, so there's no parts on it, but yeah, this is what it looks like for more like functional PCB. That you see the black and the copper.
Totally.
multiple layers too.
And so I'm gonna upload the Gerbers that I just zipped together, open it up in OshPark. Just thinking. And then this is really nice because then it shows you what both sides of the board is gonna look like very clearly. And even this is another sanity check that I find really helpful. What's my ticket? I don't actually really want to log in though. But anyway, so this can be used for ordering it.
Does it estimate the cost for
It does. Oh, right here. Three boards will cost $15.70. So it's it's a 2-layer board.
Yeah, I was just looking online for that same question.
Yeah, and this board is right under 2 inches tall, so it's like a little, little cat, something, It's just a little cat hanging out. So, and yeah.
So you would do this, and then separately you would go order all the other parts.
Yes. Yes, and I would order the other parts for it if I didn't have it on hand already.
Are there places that would do, like, populate the board for you too?
Yes, there definitely is, and I can show you that next. After you've ordered your first board and you're ready to kind of level up, I recommend JLC PCB. They are based in Shenzhen, and this is where I get my boards made. All of these came from JLC PCB, and I can order stuff there like 200 to 500 at a time. And so OshPark is an okay deal for the prototype run, just three boards, because they will ship locally from within the U.S., so you're not paying shipping or expensive shipping or tariffs for it.
Tariffs
Especially tariffs. They get real crazy. So it's good to plan that if you're trying to figure out the cost of doing a project. Remember that I think it's up to 37.5% additional
It can vary a lot.
tariffs. Yeah,
I had 25 to 50%.
yeah, yeah. I got hit with like 200% when things were real crazy.
Is it still cheaper than going to like OshPark or some other place locally?
You would be surprised. It does end up balancing out once you get into the higher quantities. But if you're just doing a prototype run and you just want to do 3, OshPark is so easy. I really like them. And so this is JLC PCB, and this is what a more advanced ordering interface looks like. And can I make my
So
font
do
bigger?
these also source the parts as well?
This does not source the parts, but you can get them to populate the parts for you. And JLC PCB and LCSC, this company, are intrinsically linked.
Oh.
I don't know if it's the same company or totally
What if
different.
we do populate the board but not source the parts?
I can kind of show this actually if you want, because I have a board of mine up.
Yeah.
So like this is a board of mine that I've ordered on JLC PCB, and so the circuit board is just like, oh yeah, you get a circuit board like this. And then the PCB is a separate thing where I've uploaded a list of all of the parts with like the part numbers on LCSC. So they'll source all of these parts, they'll buy them,
Oh, okay.
or they'll ship them over from their other warehouse. and then they'll place them down on the device. So this is like a diagram of every single part and where it would go. And so they'll actually have their pick and place robot put it all down.
Yeah.
Wow.
But yeah, so this is like 2 steps. First, they'll fabricate the circuit board like Poshmark would do, but then they'll also like buy all the parts. But you have to use only parts that are kind of in their library, or you have to like ship parts to them or have them buy them for you, which can be more expensive.
So when you run Kicad, you're going to be using the parts that they have in their library.
Yes, and in fact, there's a program called Easy EDA to Kicad, which is a Python script. But basically, if you have like all the part numbers, like these are like the LCSC part numbers, it will populate footprints and things that are just exactly the parts that you can use.
Okay.
So yeah.
Okay.
But that's like, and that's like once you're doing this, yeah, just you'll go on JLC PCB and you look at their parts library and see what kinds of parts they have. But they have a lot of stuff that you can use.
How expensive is it? Like a pre-built completely for
It can vary. I've had some students do their projects for like $100, $150, which is like
how many boards?
for like 3 to 5 boards. But it depends.
It's kind of
Yeah.
Because we're looking at like $5 per board.
Right.
And now it's like.
I imagine your boards are more complex.
But more complex with more parts. Also, you have to pay for them to set up the like pick and place robots.
Yeah.
Yeah.
Yeah,
So
the
blueprint.
initial setup fee is really like,
Right,
if
right.
you're doing a bunch, it's so worth it.
Okay.
If you do a few, it's less worth it. But
So it's worth it to print like 1,000 or something.
Totally, yeah.
I mean, if you're gonna prototype something, you don't wanna prototype it on that site before
Right.
buying 100 of them.
Yeah, for sure.
You're gonna have to get like something.
what I like to do, like I was looking at this order and it was like 100, it was $200 plus shipping for like 5 of like this board that I'm working on. But then once that's dialed in, I can just up that to 100 boards
right,
and
right.
the setup fees are all the same.
Right, okay, cool.
Totally.
So they do 3D printing too.
Oh yeah, they'll do 3D printing. They'll make the stencils also for it. Like you can this one's so simple, you can hand solder it, but if it's more complex, you'll get like a silk, like a stencil for it. So you'll almost like silk screen squeegee the solder paste onto there. And then you place the parts, put it on a hot plate or put it in an oven, and then and it's real satisfying when you get to that point. I rather enjoy that. But so for this though, you can just choose if you want 5, 10, 50, 70,000 copies,
Yeah.
you know?
As many as you want.
They will do whatever you want. And so the cost of it varies for it. So like if you do 100, it always updates over here, the calculated price. Is that for it?
The price per board or total?
Flexible.
Okay, we recommend you prototype your PCBs first before getting 100 of them, even though they're telling you.
So like they're not testing for you, it's like
Yes.
No.
you can make expensive mistakes.
Yes, you super can.
That's just
Yeah, I know, I was about to say. So for this, there's like, they're like setup engineering fee, some film, I don't know if that's like the stuff in between. Making the board, $15, nothing, you know? But then the price for it though is, then it's like the shipping estimate, so it's gonna be like, the cost of shipping is more than the board itself. And so, and this is DDP actually, why did it go away?
There's a rabbit hole.
Yeah, if there is the option to do DDP, I recommend it, and that is where they are prepaying the tariffs for you. So you're paying it up front, and they are handling that. You can do it without it. I don't know why this doesn't show a price difference between the two right now.
It'll calculate it, shipping.
Once I go further down,
I've got
yeah.
a horror story for this one. Actually, you don't know this story.
Oh.
For the circuit boards for my last run of my product sensor watch, I decided not to do DDP. I'm like, I'll handle customs on my own when I get here.
Duh.
That's when they miscategorized my parts as automotive parts and charged me 50% tariff on them.
Yeah.
So, yeah.
Yeah, and they won't tell you what that is until after it's crossed the border into America.
And then it's like, you now have
Their whole-
72 hours to pay or we're going to destroy the package.
Yeah,
Oh.
so it's like a ransom note when it happens. It's like really bad. So anytime you can just prepay it, it just, you know, they know what they're doing better than the customs in America do. They just, yeah.
Definitely, yeah. In stock at Crowd Supply as of day before yesterday.
Nice.
I was gonna ask you a lot.
Yeah, And so in here, there's more customization. You can choose those different color silk screens I was talking about. I always recommend selecting lead-free Hazel. You can get it with lead. It's a little bit cheaper, but just spend a couple bucks and be lead-free.
You can also get it with gold, which is pretty, and a little bit more expensive.
Yeah, so this will go from $30 predicted price up to 44. That's not too crazy.
For gold plating, I mean, you know.
Yeah, and that's for 100 of these too. So like, you think about how much once it's all said and done, you know, throw on parts, throw on shipping and all of that, like it works out. I mean, just for kicks, what happens if you do 1,000 of them, you know? It goes up to 220, so you just did 10x, and then it did not go up by 10x at all, so we're not going to talk about the tariffs that hit on the end of that though. But looking at it at this number, it looks real nice. And then every time you change that, it resets some of this, so you always got to go back and reselect the lead-free. And so you can do PCB assembly if you want them to. Oh, we recommend panelizing. You can adjust this to meet it, and they will panelize it for you.
That's new.
Yeah.
I haven't seen that pop up before.
Yeah, and I just clicked it earlier too, and it didn't show up, but now it did, so that's cool. And so for the PCB assembly, we got to let them know parts go on the bottom side, assemblies only on the bottom side.
What does that mean?
It's just letting them know that all the parts they're going to be placing are on this side of the board, and if it's complicated, maybe they want to be there's parts on both sides. But for this one, like, they'll ask too, usually, but edge rails, we're going to let them do this. Confirm parts placement. This is, they will email you to confirm that everything looks good, because their engineers will make subtle changes to your product and not tell you sometimes, so it's always good to double check to make sure that they don't mess it up. And they're warning you it's gonna take more time, confirm within 72 hours. And this, you can do self-service part selection. There is this one that's by JLC PCB, but they'll charge you $10. I actually haven't tried this.
I haven't tried that either. I'm always super expert on my parts.
Yeah, and especially for yours, because it's very specific for some of it. But I don't know, maybe if we're just doing, no, because it's reverse mount LEDs too. So I would recommend doing it yourself. So all this advanced stuff, you don't really need to worry about it. This is for like real high quality stuff. They can do a probe test, high temp solder paste. Oh, that's kind of neat.
I've never used the fancy options.
Yeah, bake components, that's where they preheat it before putting it on the board. And when I worked at a synthesizer company, we did have a whole bunch of failed boards because the LEDs were in a humid environment, and then they sent it through the reflow oven without baking it first, and there's all these failures. Like, it was a huge batch of boards that all had problems, and we discovered it was because they didn't bake their LEDs. They were sitting in a humid environment. Stencil, huh? 4MS. It was a Eurorack modular synthesizer company. And they're still around. They make really great products. You can get a stencil if you want to do at-home stuff also and set up your own little squeegee station. But for this, we're going to select our own parts. So $36 for 5 panels, which will be 150 pieces.
What's that panel?
The panel, there was like this weird menu option that popped up earlier. They will panelize it for you.
You pop them out.
Yeah, you can like snap them apart. And so when they do these runs, they typically are going to panelize it. There's a really cool photo that I found from Osh Park one time, because they do all these 3 at a time things. The way that they do that is that they take everybody's orders that come in over a period of time and make one giant panel with everybody's parts on there, because then when it goes through the machines in Shenzhen or wherever, they want to have the standardized rail width, so it goes through the machine, and it has a machine that uses a little vacuum pick and place. It goes and drops all the parts on there, and it's at lightning fast speed. I've got videos of it when we were at the factories, like, oh my god, it's so cool. So this shows a preview of it, just like one final sanity check before you order it. Go to next, and then,
This is a panel.
oh, you found a panel?
So this is like the board inside my watch, but like they kind of make a grid of them, and
Oh yeah,
So
perfect.
when you snap them off.
and yeah,
Yeah.
you can either snap them off, or there's actually tools that help, like there's exactly the width of these little like mouse bite things, and you like put them off once they're assembled.
Yeah,
So yeah.
totally. And like I get these in panels when they come in, and it connects to these flat sides right here, and it has like a little bit of leftover that you have to get rid of. And so at this stage, you would have to add a BOM file, which is a standardized view of, let's open, what the fuck? Oh, a standardized like spreadsheet that will say like the part, location, manufacturer number, all the stuff that they need to know what part it is. And then yeah, I can't move forward without doing that. But that is kind of the gist of it. I hit back, so it's gonna get mad about that, so we'll open it up again. Just for kicks, we gotta show off how expensive it gets. But it's not too bad. Too black, lead free. Make it a cool looking cat. 100, we're not doing PCB assembly, we're gonna do it at home.